joined by now.
All right.
So today we are going to look at polynomials. So we've been looking at functions. So we've looked at linear functions. We also looked at quadratic functions. So polynomials as well are functions, but we'll maybe just another special type of functions. So let's define what a polynomial is. So we have, so we can say a polynomial degree n, the function of the form So this is a function of the form. So we have f of x being equal to x power n plus n minus 1, x to the power n minus 1, plus then all the way up to say a1 plus to a naught. So that is what a polynomial is. So a polynomial of degree n is simply a function of this form. F of x is equal to an x to the power n plus an minus 1. So where we have that, this an a1 all the way up to this one here. These are constants in a polynomial. So that's what we have. So these n minus 1 and a naught are constants. So in this case, x is the and x is the variable. So that is what the variable is. So x changes, where x is the variable. So an example, so e.g. we have f of x being equal to x to the power 3 minus 5 x squared plus x minus 7. We also have, say, these are functions, x to the power 30, so minus 2x plus 5. So those are examples of function of polynomials. This polynomial here, we say it is, so we say the polynomial of degree n is this function here. And then when you look at this, so we're going to say this is of, are we able to see that? No. So this one has degree 3. Then this one here has degree 30. So that is what a polynomial is. So the degree of a polynomial is simply the highest power in that polynomial. That is the degree of the function, polynomial function. Okay, so from here, I want us to proceed straight into division of polynomials. How many people do we have now?
16.
How is everyone? Okay. Some people are not responding. Okay. So if we say let f of x a polynomial of, say, degree n, this n should be greater or equal to 2. So we have that let f of x can be decomposed into polynomials so into polynomials of lower degrees. Sorry, that's what we have. So if f of x is function, then we can say f of x can be expressed as decomposed into, we have that the d of x times the q of x, then plus the r of x. So where we have that, this one here is the divisor, this one here is the quotient, and this one here is the remainder. So that's what we have there. And then, so it can be expressed like this, or which simply is the same as, say, f of x over this d of x is equal to the q of x plus r of x over d of x, remainder, divisor, and the quotient. So we can use, there are about 2 methods that you can use to divide polynomials. So we are going to look at 2 methods, synthetic division and long division. So we are going to start with long division first. So long division. So example. So look at an example. So determine, so you say determine whether this one here, x minus 1, x minus 1 is a factor of x being equal to x to the power 3 plus 3x squared. Okay, just copy the function there. 3x squared plus 3x plus 1. So we want to determine whether x minus 1, this is a linear term, x minus 1, if it is a factor of this polynomial here, polynomial function. So we can, this is how we use long division. So you can divide, so we are dividing this x minus 1 into this one. So we are going to have x to the power 3 plus 3x squared plus 3x plus 1. So here you're going to consider the x term in the linear term, here. So you're going to consider the x, you divide it in the first term of the polynomial function. It's going to give you x squared, the x squared you put there, then you multiply. So x squared times this one, you get x squared minus x to the power 3 minus x squared. And then here you subtract. So you're going to get 0 there, then there you're going to get, what are you going to get? You get 4x squared. So you have to know there is a plus 0x and a plus 0 there. So this one, so you simply get 3x plus 1. Then this one here comes here, you divide here, you're going to get 4x, positive 4x, you put there, then you multiply there, you get 4x squared minus 4x. Here you also subtract this one, minus this one is 0. Then 3x minus 4x, you get 7x. Then this one will come here, plus 1. Then x into this one, you divide again. So you're going to get plus 7 there. Then 7 times this one, you get 7x minus 7. So even here, you subtract. So what are you going to get? This is 0, this is 8. So you get 8 there. So you know what we mean by a factor. So a factor is a number which can go into a number without leaving a remainder. So since we have a remainder here, you can conclude that x minus 1 is not a factor of this polynomial function here. So if they've told you to determine whether x minus 1 is a factor of f of x, so meaning you can conclude, so since, okay, not therefore, you can say since there's a remainder here, since the remainder is equal to 8, we can conclude that x minus 1 is not a factor of f of x. The f of x is this one here. Okay, can we move on?
Yes, sir. We can move on.
Sir, I've got a question.
Yes, question.
There where is that 2? There where we're having 4x squared plus, is it 2x?
That's 3x.
Oh, okay.
Yes, this 3x.
Okay, thank you.
So that's the long division that we have. So remember what we said about the decomposition of a polynomial function. So in this case, we have that. We have the divisor, which is x minus 1, the quotient here, and the remainder we have 8. So this f of x can be written in this form again. We can also write it like this. So f of x is equal to there's x minus 1, the dividend, the divisor, I mean, then times the quotient, which is x squared plus 4x plus 7. Then plus what? The error of x, which is 8. So that is another way you can write this function of x here. So you find that when you multiply, when you do multiplication, you still get back to that. That's what we mean by decomposition. Okay. Let us look at, so I want us to be very quick. We can look at synthetic division. So we're going to use the same function. So the question is, so example, we look at an example using synthetic division. So determine the quotient the remainder when so this f of x here equals to x to the power 3 plus 3x squared plus 3x plus 1 this one is divided by the same x minus 1. Okay, so for synthetic division, first things first, you are going to let the linear term here equal to 0. You equate this one to 0, so you are going to have x minus 1 being equal to 0. Then you're going to have that x is equal to 1 here. Then what you do next is you're going to get the coefficients of all the coefficients of the polynomial function there. So you're going to have the first coefficient there is 1. Then we have 3. Then we have 3 again. Then we have another 1. All the coefficients of f of x. Then we are going to divide this one by 1 like this. So there, first, you're going to put a 0 there. And then you are going to be adding. So when you add 1 plus 0, you're going to get 1. And then the next step you're going to get is to go to is 1 times 1. You're going to get 1. You put it there. Then you add 3 plus 1. You're going to get 4. Then you're going to multiply this 1 times this 4, which is a 4. You put there. Then you're going to add 3 plus 4. You're going to get 7. Then 1 times 7 to give you 7 there. Then 1 plus 7 to give you 8. So using synthetic division, you have that this is the remainder of x. And how do you obtain the quotient? The quotient is this one here. So the q of x in this case is equal to, we have, remember this is of degree 3. So the quotient obviously is supposed to be, the first term is supposed to be squared. So you have, this is 1, x squared, then plus, this is 4x is the next term, then plus this one here, plus 7. So this x squared for x 7. So the remainder, so in this case, we are being asked to determine the quotient and the remainder when f of x here is divided by this one. So the quotient is this one, right? Which you found, and then the remainder is this one here. So you can conclude to say, therefore, so the remainder r of x is equal to 8, and the q of x there is equal to this one here, x squared plus 4x plus 7. So I just want to do this quickly, then we can look at questions. So that is synthetic division. So you can practice on this. Okay, another thing that I want us to look at is the factor theorem. Factor theorem. Okay, do we know the factor theorem? So the factor theorem says if f of x, so you can let f of x be a polynomial of degree n, and you can let this px plus q be a linear term. Be a linear term. So you have that if you say f of minus q over p is equal to 0, then px plus q is a factor of f of x. So that's what we have there. And conversely, if the converse now will say if this one p of x plus q is a factor of f of x, then f of this one is equal to 0. That's the converse. So let's look at an example of the factor theorem, so we see what we mean here. Example, so you can say show that x minus 1 is a factor this function now is a factor of x to the power 3 to the power 3 minus 6x squared minus x plus 6. So we can use the factor theorem to show that x minus 1 is a factor of this polynomial here, this f of x here. So how do we achieve that? So the first thing, again, we are going to equate this one to 0. So you let x minus 1 equal to 0, so that x is equal to 1. Then you find f of 1 there, which would be 1 to the power 3 minus 6, 1 squared minus 1 plus 6, which is equal to, this is 1 minus, this is 6 minus 1 plus 6. So we see that 6 and 6, this is plus 6, this is minus 6, they'll go. This is plus 1, this is minus 1, they'll go. So this will give you 0. So according to the factor theorem, since the remainder is 0, I mean f of 1 is 0, we can conclude that x minus 1, therefore x minus 1 is a factor of f of x, this f of x here. Okay, can we move on?
Yes, sir.
Yes, I can move on.
Okay, another theorem that I wanted us to look at is the remainder theorem. These are important. So the remainder theorem. So we're saying this one says let f of x be a polynomial of degree n greater or equal to 2. So we're saying if f of x is divided by a linear function, by a linear term, this linear term here, px plus q, then we have that the remainder is simply is f of this one q over p. So that is what the remainder theorem says. So let f of x be a polynomial of degree n, which is greater or equal to 2. And if f of x is divided by a linear term, then this linear term, then the remainder is simply f of minus q over p, which you can obtain by equating this one to 0. Example. Find the remainder when this f of x go to x to the power 3 minus x squared plus 3x minus 2 is divided by what's that, 2x minus 1. This is 1, this is 1 here. So find the remainder when f of x is equal to x to the power 3 minus x squared plus 3x minus 2 is divided by 2x minus 1. So that's the problem that you have. So you can use the remainder theorem here to determine the remainder when this function here is divided by this linear term here. So the first thing is, okay, you can say, so you let 2x minus 1 being equal to 0, and you have that 2x is equal to 1, and you get your x as 1 over 2. So the remainder will be f of 1 over 2, guys. So which will be equal to 1 over 2 to the power 3 minus 1 over 2 to the power 2 plus 3 by 1 over 2. Then we have minus 2. So this is going to give us, this is 1 over 8 minus, this is 1 over 4. This is 1 over 4. Then this is plus 3 over 2, then minus 2 there. So if you try and work out this one here, don't skip a step. You're going to get negative 5 over 8. So that is the remainder. So the remainder, when this polynomial function is divided by 2x minus 1, is this one here, minus 5 over 8. Simple and straightforward. That's the remainder theorem.
Sir, tell that one to switch off.
Can't get you. Hello?
I think he was making a request for someone's mic being on. He was trying to ask you to tell someone to switch off their mic.
Oh, it's disturbing. Okay, somebody switch off the mic.
Oh, he was trying to say, tell the one who is sharing the screen to switch off.
Who's that one? I think we are only the two of us that are able to do that. But are you able to see what I'm doing here?
Yes, sir.
Okay.
Sure, sir.
So I want us to look at, so there is a tutorial sheet, 2018 UNZA tutorial sheet. So there are questions on polynomials. So I want us to look at 2 or 3 questions from that tutorial sheet, 2018. Those of you that have on polynomials, you can check it out. Which one are we going to start with? Okay, we're also going to look at how to sketch the graph of the polynomial. So don't just forget what you're doing. Okay. So is this going to be visible? That's visible, huh? So you can just copy that question. Let me put it this way, you turn your phones around. Okay. So that's the question we are doing. So we have a minute to copy that question, then we do it.
Sir. Hello, hello, sir.
Yes.
Are you not going to send the same tutorial sheet in the group?
Actually, okay, right now I have a bit of the I don't have a phone at the moment. I'm yet to find one.
Maybe it can be a good suggestion.
Okay, I'll tell someone to share with you. So someone will share the question, but for now, I don't know. Okay, the thing is, I don't know. This is question number what? I didn't even indicate. Okay, but let's just do it. I'm sure you're able to see. So this is the question that we have. So show that x minus 2 is a factor of that. Hence, or otherwise, find the exact solutions of the equation f of x is equal to 0. So you see a factor when you divide. So when you divide this linear term, when you divide this polynomial by this linear term, you should get a 0. That's what we mean by factor. So by showing, how do you show? Using the factor theorem, we let solution. So we are going to let x minus 2 equals 0. So this will imply that x is equal to 2. That's what we have there. Then you find f of 2. So f of 2 is equal to, we have that is 2 to the power 3 plus 2 squared minus 5 by 2, then minus 2. So what are we going to have? 2 to the power 3 is 8, plus 2 to the power of 2 is 4, then minus 10, then minus 2. So what do we get here? So we have 8 plus 4, which is 12, minus 10. This is minus 10 minus 2. You're going to get minus 12, which you're going to get 0. You have shown. So you can say, since r of x is equal to 0, x minus 2 is a factor of this one here. So that's what we do. Since r of x is equal to 0, since the remainder is 0, so meaning this one is completely divisible by x minus 2. So the question goes on, hence or otherwise find the exact solutions of the equation f of x is equal to 0. So f of x is equal to 0 implies that This find the polynomial x to the power 3 plus x squared minus 5x minus 2 is equal to 0. Are we following there? So what you need to do here, since you've been given one factor, so you're going to use that factor now. You are going to either use synthetic division or long division, whichever will be convenient for you. So let's use synthetic division here. So we are going to divide this x minus 2 into this one. Then, so we have the coefficient first. Another coefficient is 1 there. Then we have the coefficient of this x minus 5. Then finally, we have minus 2 there. Then here, we let x minus 2 equal to 0 and x equal to 2. So we are going to have that. We are dividing this one by that. So the 2 come there. So like that. So that is synthetic division. So it's 0 there. So 1 plus 0, you get 1. Then 2 times 1, you get 2. Then you have 1 plus 2, you get 3. 2 times 3, you get 6. You add this one plus this one, you are going to get a 1. 2 times this one here is 2. Negative 2 plus 2, you're going to get 0, which is equal to the remainder, r of x there. This one, remember what we did here. So the quotient is going to be x squared plus 3x plus this one here plus 1. Are we together? So let's continue. So let's continue on this other paper. So therefore, you can decompose the f of x as follows. So we can say f of x now is equal to, you have d of x times the q of x, then plus the r of x there. So in this case, our d of x is x minus 2, the one we've been given. So it's x minus 2. Then times this one here, the quotient, which is x squared plus 3x, then plus 1. Then plus the remainder, which is 0. So the question is, find the exact solutions to the equation f of x is equal to 0. So that's what we mean. So simply, so you're going to equate this one to 0. So you have x minus 2, then you have x squared plus 3x plus 1 being equal to 0. So those are the solutions that you're looking for. Okay. So in this case, so we are going to deal with this one now. So you have x minus 2. You can factorize this one. It's in the factorization method. So this is x squared so what factors do we have there?
There are no factors.
There are no factors there. So what do we do if there are no factors?
I think we are going to use long division.
Long division. Okay, so you can do this. So x is equal to minus b plus minus the root of b squared minus 4ac over 2a. This one minus b, that's minus 3 there, plus minus the root of b squared, which is this squared is 9, that's a 3, then minus 4ac, which will give you a 4 over 2 times 1, which will give you a 2. So this will be equal to, well, this was a question. So this will be plus minus 3 plus minus the root of 5 over 2. So this is equal to minus 3 plus, so x is equal to minus 3 plus the root of 5 over 2. And we have that x is equal to minus 3 minus the root of 5 over 2. Are we together? So how are we going to write this one? So this one will be x minus 2 times this one. How do you write it? So you have that x, when it goes this side, so that is a factor. So x is equal to that, remember? So we are going to have x minus 3 minus the root of 5 over 2. Then also this one here, when it goes like that, you're going to have x plus 3 then don't forget this is equal to 0. Okay, are we done copying that?
Sir,
Therefore, we have that.
sir, I have a question.
Yes.
On that other one, the last one, isn't it supposed to be x minus 3 plus root of 5 over 2?
Which one?
The last one.
This one is supposed to be
X minus 3 plus root of 5 over 2. Shouldn't the positive sign only be in between 3 and root of 5?
3 and root of 5.
It's a question I'm asking.
So you have that when you have 2 roots of a what? So you have say maybe, okay, let's do this. So say, so alpha and beta are 2 roots of a quadratic function, polynomial. Then we have that x minus alpha times x minus beta is equal to 0. Is that correct? So if this is a factor, okay, so this is x, so you're going to have x minus 3 plus the root of 5 over 2. Then what are we going to have? You're going to have x, this is plus 3 minus the root of 5 over 2. Okay. That's what you're saying. Then with this one now, we are going to have that this is x minus this one here. Two. And this one you're going to have x, this one will be 3 plus 5 over 2. I don't know if that makes sense.
Yeah,
Fine, sir.
makes sense.
So we have two roots here. Okay. So we have that this is equal to 0, what you have here. So the equation now, the exact solutions are x minus 2 being equal to 0 here. So which we are going to have x being equal to 2. And the other ones, I'm sure you've already solved because you have that x is equal to this and x is equal to that here also. So these are two roots of this function here, the quadratic function there. Okay, sorry about that. So you've already solved here. You have x being equal to this and x being equal to this. So x is equal to 2 and x is equal to here minus 3 plus the root of 5 over 2. Also this one here, x is equal to which one here? This one, minus 3 minus the root of 5 over 2. So these are the exact solutions to the equation f of x is equal to 0. So that's what we have. Okay, so you have another question here. So this is also from the same tutorial sheet. You have that given that x minus 1 and x plus 1 are factors of this polynomial here, px to the power 3 plus qx squared minus 3x minus 7. Find the values of p and q. So that is a question from the tutorial sheet. Solution. So with this one, you have that given that x minus 1 and x plus 1 are factors of this polynomial function. Find the values of p and q. So here what you need to do is this one, if this one is a factor, then the remainder, when you divide this one linear term here, when you divide this polynomial by this linear term here, you get the remainder of 0. Even when you divide this function by this linear term, you're also going to get the remainder 0. So you start with x minus 1. So we can let x minus 1 equal to 0. Then we are going to have that x is equal to 1 in this case. Then you can say, okay, you can let this p of x say, okay, so you can, okay, let's just do this. Let f of x equal to this one here. the px to the power 3 plus qx squared minus 3x and minus 7. So you're going to find f of 1 here. So f of 1 now is equal to, when you consider this one, you have that p times 1 to the power 3, then plus q to the power times 1 to the power 2, then you have minus 3 times 1, then you have minus 7 there. So this one is going to give you p 1 to the power 3 is 1 plus q, then minus 3 minus 7, guys. So this one is going to give you p plus q minus 10. But since this one they've said is a factor of this function here, so you're going to have that this one here, p plus q minus 10 will give you a 0. So you can name that as your equation 1. So you consider the other one as well. So you say, let x plus 1 equal to 0 now, so that x is equal to negative 1. Then you find f of negative 1 here. We're using the remainder theorem here. So f of negative 1 now is equal to p of minus 1 to the power 3 plus q of minus 1 squared, q of minus 1 squared there, minus 3 times minus 1, then you have minus 7 there. Then this is going to give you negative 1 to the power 3 is negative 1, then times this one you get minus p. And this one here, you have its positive, you have plus q. Here you're going to get a positive plus 3, then minus 7. So you have that this one is equal to minus p plus q plus, okay, plus minus 4. Yeah. So which is going to equal to minus p plus q minus 4. So again, since x plus 1 is a factor of that polynomial, you're going to have that minus p plus q minus 4 will also give you a 0. So this one you can name it as equation 2 as well. So what you're going to do is to find the values of p and q, you're going to solve these two equations, equation 1 and equation 2, simultaneously. So you're going to have, so we have two equations. So the first equation is p plus q minus 10 being equal to 0. So you have p plus q equal to 10. So that is your equation 1. Then you have this one here, minus p plus q minus 4 is also equal to 0, which is the same as minus p plus q is equal to 4. That is your equation 2. So when you solve equation 1 and 2 simultaneously, okay, let's put them here. So you have p plus q equal to 10 and minus p plus q equal to 4. So here you can use the elimination method, guys. It's going to be very simple. Say you can add there. So p plus minus p, you get a 0, then q plus q, you get 2q, which will give you 10 plus 4, you're going to get 14. So q is going to be 14 over 2. So q is equal to 7. So that's the value of q. So to find the value of, you can, the other variable, which is p. So you can use each one. Which one are you going to use? Okay, let's use this one here. So you have that p plus q is equal to 10. So there we're going to have that Q is 7. So you have that P plus 7 is equal to 10. Then P is equal to 10 minus 7. So P is going to give you a 3 there. So you can say, therefore, Q is equal to 7 and P is equal to 3. Oh, 1706. Okay, we can take a short break, then we come back. We do another example on polynomial. And I wanted us to look at on how to sketch the graph. If time is going to allow, we are going to look at it. Look at radical functions. Radical functions.
What time are we going to start to continue?
Okay, we are going to take. I'm still talking. We are going to take a 5-minute break. So we continue now. We are continuing. We are going up to 18 hours. So let's just take a 5-minute break, then